All right, now we're going to do some matrix multiplication.
Definitely have a highlighter maybe as you go through this one. I think it'll help a little bit.
This is tricky to keep track of.
Yes.
So we're going to use matrix multiplication to find AB and BA. So this is the case where these are going to be different. Whenever we normally multiply numbers together, like 5 times 3, that's the same as 3 times 5.
Right.
That's called being commutative. Matrix multiplication does not have that property.
No, it does not.
So
which makes it a little bit more difficult because you think that it does.
Yeah. So to do A times B, how even to explain this? This is
Well, you're going to take the first row, the elements of the first row, and you're going to multiply each individual element of the first row with the first column of the other matrix, and then you're going to add those little pieces up.
All right.
So this is the first step, looks exactly like what Mrs. Stevenson has written.
Right, so we take that's backwards. We take the first row and the first column, and what that finds us is where they overlap. That's going to find us element 1, 1.
Which means that we're going to be in row 1, column 1 when we get done.
So what we do is we do 2 times 1 plus 3 times negative 2. Which is
2 minus 6.
Negative 4.
So negative 4 goes into row 1, column 1. All right.
Okay. So now let's do the next thing. So we do now the first row and the second column.
Right.
Where those overlap, which is the element in the top right corner.
Right.
That's where we're going to put that answer. So 2.
So row 1. Column 2,
2,
and you multiply each individual element.
So first and first, 2 and negative 3 plus 3 and negative 4. So that's negative 6.
Minus 12.
Minus 12.
Negative 18.
And
so
that goes
row
to the
1,
top right.
Column 2.
New color. All right, now we're going to do the second row. So second row.
Second row.
First column.
First column.
So you're going to do negative 1 times 1 plus 5 times negative 2. So negative 1 minus 10.
Negative 9.
Negative 11.
That's what I said?
Yep. Totally.
Totally what I said. I don't know how you messed it up.
Row 2 and column 2. So that gives us negative 1 times negative 3 plus 5 times negative 4.
Right. And there's some patterns that occur here as well that you can see. Maybe a little bit easier if we had actually written these into the spots of the matrix where they were going.
Oh, you know, that would have probably been...
Well, go ahead and write it down right now. This is what you should get when you multiply A and B. So, okay, Steve, write in blue what you have written in blue right here. Put that in row 1, column 1. Big matrix style now.
2 times 1.
Write it exactly like that. Don't write the equals part. Yep. And then underneath that, and next to that is red. So red would be over here in this one.
2 times negative 3 plus 3 times negative 4.
Then purple in the lower left-hand corner.
Negative 1 times 1 plus 5 times negative 2.
And then green in the lower right-hand corner.
Negative 1 times negative 3 plus 5 times negative 4.
Okay, now notice there's some things that occur here. If you look in all of these by column, okay, notice that you have all 1s and all negative 2s.
Right. And
okay.
then
you have all negative 3s and all negative 4s. And then on the other side of that, if you'll look, you'll have the actual first matrix represented. So see the 2, 3, negative 1, 5?
Yeah, 2, 3, negative 1, 5.
Okay.
And then 2, 3, negative 1, 5.
There you go.
Again over here.
Yes. And so that's kind of another pattern that you can look for when you're multiplying the matrix.
Right. Now, for me to do B times A, I almost have to like write them in the other order.
Yes, you need to, or you'll make a mistake.
What happens is we're switching which rows and which columns we're dealing with. And for whatever reason, it doesn't really work so well whenever I try to do it personally in my head. So for BA, we've got first row, first column. So that's 1 times 2 plus negative 3 times negative 1.
Can we show them the pattern for this first one then?
So then here we should have
Negative 2 times 2.
Negative 2 times 2 because this is the bottom left
Right.
here, and then the 2's match up.
Plus
and then,
negative 4 times negative 1.
right. Because the second number is the same in the columns.
Right.
And then the first number comes from what is the first matrix that we have, which is B.
And if you don't see that right away, that's okay. Write it out like Casey did on the first time
Right.
through.
So let's start this here. Negative 2, negative 4, and 3, 5.
Negative 2, negative 4, negative... No.
No, just kidding. I want...
No. No. 1, negative 3.
1 negative... This is terrible.
1, negative 3, 3, 5.
1, negative 3...
3, 5.
3, 5.
Yeah.
Okay.
See, it's tricky. You
It
got to
is
pay
tricky.
attention.
1 times 3.
Yep.
Plus negative 3
Times 5. And then we can fill in the rest of the pattern there. So it's going to be negative 2 times 3 plus negative 4 times 5.
And then we just have to actually figure out what all these are.
Yeah.
So this is 2 plus 4, which is 6. 3 minus 15, which
Negative
is
12.
Negative 4 plus 4, which is 0. Negative 6 minus 20, which is negative 26.
And you can have 0 in a matrix. That doesn't
fine.
mess anything up. 0 is a number.
Yeah.
So it's okay to have in there.
Okay.
All right, good talk.